Okay, so let's have a look at the 2021 Higher Level Leaving Cert Maths Paper 1, question 10. In part A here we have water. It's flowing into and being removed from a tank. The volume of water in the tank is measured on a daily basis starting at day 0. The volume of water is in litres. In the tank can be modelled by this formula here. V of t is always greater than 0. Now t is an element of or and it's in days, so t is in days starting at day 0. Use the function v of t to answer the following 4 questions. Find the value of t when the tank is empty. So our formula is v of t is equal to 60 plus 41t minus 3t squared. So when the tank is empty just means that v of t is 0. So we'll have 0 here. Okay, so what I'm going to do here is just multiply across by minus 1 just to put this t squared first and also just get rid of that minus. So I've got 0 here, I've got 3t squared. It's going to be minus 41t and then minus 60. So the next thing I've got to do here is just solve for t. So we can do it the usual way, or you can use the quadratic formula, whatever way you want to do it. But it's not too difficult this way, I think. So you've got 60 here, so you can list all the factors of 60. So the ones that work are 15 times 4. So I'm going to put the 15 here and the 4 here. Now 3 15s is going to be 45, and I also have a 4 here, so I can get a 41 from that, no problem. So I need the bigger one to be minus, so again I'm going to put the minus here and the plus here because we need plus times minus to give us that minus there. So anyway, looking at this then we can see that 3t plus 4 is equal to 0 and t minus 15 is equal to 0. That'll give you t is equal to minus 4 over 3 or 15. Now remember, t is time in days, so we can't have t equal to minus 4 over 3. So the answer here is 15 days. So it takes 15 days for the tank to empty. Okay, so let's have a look at the next one then, part 2. Find the rate at which the volume of water in the tank is changing when t is equal to 5. The rate at which the volume of water in the tank is changing, that's just differentiation. So let's take our original function, which is v of t, and that's going to be 60 plus 41t minus 3t squared, and we want v dash t here. That's going to be that'll be 0 there. We'll have 41 here, and then minus 6t here. So that's our v prime t. Now we want t to be 5, so we want v prime 5. So that's just going to be 41 minus 6 times 5, and when you do that then you get the rate of change when t is 5 as 11. So that's going to be 11 litres per day. Remember, the volume here is in litres and the time here is in days. Okay, so find the value of t when the volume of water in the tank is at a maximum. So whenever we see these words maximum, minimum, usually we look at differentiating the function and letting it equal to 0. So our v dash t here again is v dash t here is just 41 minus 6t. So we want 41 minus 6t equal to 0. That gives you minus 6t equal to minus 41, and then finally that'll give us t here is equal to 41 over 6. 41 over 6 days. Now let's see, does it ask us to give our answer in a particular format? Let me have a look. Find the value of t when the volume of water in the tank is at a maximum. Okay, so it doesn't say we have to give it to any number of decimal places or anything like that. So really I'm just going to leave it like that. Okay, find the maximum volume of water in the tank correct to the nearest litre. So we have the time, so what we've got to do is find the maximum volume of water then. So all we've got to do is take our original function, which is v of t is equal to 60 plus 41t minus 3t squared. So we want v of 41 over 6. So that's 60 plus 41 over 6 minus 3 times 41 over 6 squared. Now when you do that again, that's just calculator work, so you get 200.083 repeated, and we want our answer correct to the nearest litre, so that volume is going to be 200 litres to the nearest litre. Okay, that's it for part A. Let's have a look at part B. So in part B here we have trees of the same age, size and type are growing at the same rate in a forest. It is possible to measure the radius of the trunk of a tree at the end of each growing season. The increase in the radius of the trunks of these trees each year in centimeters during a particular 10-year period can be modeled by the formula I of t is equal to 1.5 plus sine pi t over 5. Now that gives you the increase. It doesn't give you the radius or the diameter. This gives you how much the tree is increasing by each year. So t is between 1 and 10, and t is a natural number measured in years. So you can see here, if we look at our formula here, it's a sine function. So we've got a 1.5 here, and we're adding sine of of this pi t over 5. So if t goes from 1 up to 10, really we're going from 1 year, the first year will be 1t over 5, or just sine t over 5. The 10th year is going to be 10t over 5, or just 2 pi. So this will be sine of 2 pi here, and the sine of 2 pi we know is just 0. So that's the first formula anyway. Therefore it says R1 is R0 plus I1. So R0, I'm assuming, is the, well, they tell you down here, R1 is the radius of the trunk of the tree at the beginning of year 1. So R0 is the radius at the beginning of year 1. Now I1 then is going to be the increase at the end of year 1, how much the radius has increased at the end of year 1. So R2 here will just be the radius at the end of year 1 plus the increase during year 2, the increase in the radius during year 2. So in other words, the radius at any particular time plus 1 is just equal to the radius at time t plus the increase during that time t plus 1. First question then, in order for the model to be reasonable, it must satisfy a number of conditions. One condition is written below: the radius of the trees is increasing year by year. So the radius will increase each year. Show that RT satisfies this condition. So let's have a look at that. If we take our formula, so our formula for the increase, the formula for the increase is I of t is equal to 1.5 plus sine pi t over 5. Now if you take the sine function, the sine of anything is going to be between minus 1, and the y-axis is going to be between minus 1 and plus 1. So you can imagine your sine function is going to look something like that. The maximum that sine can be is plus 1, and the minimum it can be is minus 1. So if we look at the limits of this function, then on the y-axis you're looking at 0.5, because if you put in 1.5 minus 1 is equal to 0.5, 1.5 plus 1 is equal to 2.5. So that will be the range of this function, if you like. Now, so in other words, when this part of the function here is at its minimum, in other words minus 1, the entire function I of t will still be positive. So the increase will always be positive. You can say something like, since sine pi t over 5 will always be greater than minus 1, greater than or equal to, I should say, less than or equal to 1, that would mean that the IT will always be IT always be greater than or equal to 0.5. Therefore, will always be at least an increase in the radius of 0.5 centimeters. Now, that's just the way I've written it out. You may have written it out differently. There are any number of ways you could probably write that out, but that's the way I would do it anyway. Okay, so let's have a look at part 2 then. We have to show that I of 6 is less than I of 5 and explain what this means in the context of the growth of a tree. So we got to do I6 and we got to show that that's less than I of 5. So really what we just got to do is use our formula. So it's going to be 1.5 plus sine pi, put in the 6 over 5, and we got to show that that's less than 1.5 plus sine pi times 5 over 5. So what you can do here is just subtract 1.5 from both sides, and then you can just work out this, see what you get. So if you work out the left hand side here, you get minus 0.5877, goes on for a while. On the right hand side, well, that's just the sine of pi, and the sine of pi is just going to be 0. So this is true. This is true, okay? Therefore, I6 is going to be less than I5. What does this actually mean? It means that the increase in radius, in year 6, was less than the increase in year 5. The growth so there was better growth during year 5 than year 6. So again, something along those lines you can write. So in year 5 the tree grew better than it did in year 6. Maybe the weather was better or whatever. Anyway, that's part 2. Okay, so part 3 then. 2 identical trees are growing in the forest. At the beginning of year 1, a tree was cut down and a section of its trunk in the shape of a cylinder of radius 10, standard length h and volume v1 centimeters cubed was sent to the sawmill. So we have this trunk here in the shape of a cylinder. It has radius is 10 centimeters and standard height h centimeters. Now, and volume v1, so it has volume v1, and this is at the beginning of year 1. So this is the beginning of year 1. Given that R0 is equal to 10, and we can see that from the diagram there, the formula RT plus 1 is equal to RT plus I times t plus 1, where t is natural number, can be used to find the radius of the second tree for subsequent values of t. Find R2, the radius of the second tree, at t is equal to 2. Give your answer in the form a plus sine b pi over 5 plus sine c pi over 5, where a and b and c are all natural numbers. So this is kind of an unusual way to write the answer. So let's see how we get on anyway. We want to find R2, the radius at the end of the second year. That's going to be equal to the radius at the end of the first year plus I2. Now what I've done here is I'm just using this formula up here that they've given us. So RT plus 1 is R2. That's what we've got to find here, R2. That's equal to RT, the previous year, so that's R1. And then we've got to find I of t plus 1, I of 2, how much it's increased during year 2. So let's work through that then. Now R1, we're told, is just going to be 10 plus the increase during year 1 plus the increase during year 2. So what I've done here is I've just taken this bit here and written it out here. So this is the radius at the end of year 1. That's going to be equal to the original radius, or 0, which we know is 10. We're told that up here, or 0 is equal to, or 0 up here is equal to 10, plus the increase during year 1. So this is everything we need to find here. So our answer then really is going to be 10 plus the increase during year 1. The increase during year 1 is just the formula, which is 1.5 plus sine pi times 1 divided by 5. So that's this bit here. Now we got to do this one here. So that's going to be plus another 1.5 here plus sine pi times 2 this time. Pi times 2 divided by 5. Okay, so let's just kind of simplify all of this. We've got a 10, we've got a 1.5 and a 1.5 here. So that's just going to be 13. Plus sine pi over 5 plus sine 2 pi over 5. So you can see here the pattern. You're going to have some number here plus sine 1 pi over 5 plus 2 pi over sine 2 pi over 5 plus 3 pi over 5 if it was 3 years, and so on and so on. So that is the way they want the answer, I think, isn't it? A is, this is our A. Sine B, the B here is just a 1. There's a 1 there. We can put it in if you like. And then sine C over 5. So 2 is our C there. Okay, so that's it for that particular question. Let's have a look at the last part then, part 4. At t is equal to 10, the second tree was also cut down. A section of its trunk in the shape of a cylinder of radius 10, standard length h, and volume V2 was also sent to the sawmill. So V2, they're telling you, is equal to K times V1. K is real, find the value of K. Okay, so what we need to do here is look at the radius during year 10. So the radius in year 10 is going to be 10 centimeters initially. That was the R0, plus 1.5 plus sine pi over 5 times 1 plus 1.5 plus sine 2 pi over 5 plus all the way up to 1.5 plus sine pi times 10 over 5. So this is going to be the radius at the end of year 10. So if you look at all of these, you've got 10 plus you've got 10 of these 1.5s. So that's just going to be 15. 15 and 10, 25. And then you've got all these sines then. You've got sine pi over 5 plus sine 2 pi over 5 plus all the way up to plus sine 10 pi over 5. Now, if you look at this part here, all of these sines, what do they actually add up to? Well, if we just think about that for a minute, you can do them on your calculator anyway and you'll get 0. But if you think about it for a second, you've got your Aragon diagram here. So we just think about this for a little while. If we take pi over 5, that's just the same as 2 pi over 10. So in other words, if you take 2 pi, which is 360 degrees, divide it by 10, that'll give you 36 degrees. 36 degrees. So each of these pi over 5s is going to be 36 degrees. So let's just have a look at that on our Aragon diagram here. We're going to have, when we get out to here, we're going to have 5 of these, 5 pi over 5, which is just pi. So we take 36 degrees, let's say, another 36 degrees, another 36 degrees, and another 36 degrees. By the time these are all 36 degrees is here. 36 degrees here, 36. I know I don't have this to scale, but 36 degrees. And eventually you'll get out here to 180 degrees or just pi. Now, if you take the sine of each of these, take the sine of each of these, there's going to be positive here, it's going to be positive here. If you do the mirror image of all of these, which effectively is what you will end up doing here, 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 and here, the sine of all of these ones going to be negative and negative. So really, if you add all of these sines to all of these sines, when you work them out, your result is going to be 0. So in other words, when you do all of this here, the result is going to be 0. And you can confirm that on your calculator anyway. So really our radius here is going to be 25 at the end of year 10. So what do we have to do at the end of all of this? We've got to do V2 is equal to some constant times V1, or our K here is just going to be equal to V2. It's going to be equal to V2 divided by V1. So let's work out these two volumes. Now our V2, which is this one here, this is our second tree here, V2. So this is our second tree here, V2. We're looking at cylinders here, so we're going to be talking about pi. It's going to be pi r squared h over pi r squared h. So this is going to be R1 if you like, and well actually it's going to be R2 here for volume 2 and R1 here for volume 1. The pi's will cancel and the h's will cancel as well. So really what we're looking at doing to find k here is just looking at the first radius squared divided by we're looking at the second radius squared divided by the first radius squared. So that's just going to be equal to, second radius was 25 and we want to square that. The first one was 10, so we want to square that. So that'll give us 625 divided by 100, which is 6.25. 6.25. That's our value for k. That's our answer to this part of the question. And that's in fact the end of this particular question.